In the previous tutorials, all the texturing process and manipulation of UV map were done mainly on channel UV1. One cannot deny that many game engines support multiple object UV channels. In this chapter, we will scratch the surface of how to use multiple channel UVs and how to manipulate the UV map in each channel separately. We will uncover the material IDs, how to control them, and how to combine or attach objects with different materials. These are our two main objectives in this tutorial. Nevertheless, there will be other secondary objectives we will uncover, such as the differences between copy, instance, and reference cloned objects, as well as the relation between the original and the cloned object or objects. And finally, the applications of each in designing and inside modern video games. There will be some technical challenges that we need to overcome in this chapter. Without any further delay, let's jump into it. In the previous tutorial, we have completed the texturing process of this compound object, which combine the springs and the brake caliper. Let's wire the dirt map to this object. Although the dirt map rendered almost perfectly upon this object, sometimes we are limited within the default channel UV. And this is exactly the right time to start utilizing one of the most valuable features of a 3D object when it comes to texturing, which is the multiple UV channels. The closest description for this feature is like having multiple layers inside Photoshop. And you still can save those layers separately into one PSD file format. The exact same technique is used inside 3ds Max. But rather than saving the edited layers, we save the edited UV map, then they become embedded inside the 3D object. You can add the unwrap UVW modifier to either the object level or the sub-object level. In the sub-object level, select the surface or the polygons you want to unwrap or wrap. Then add unwrap UVW modifier to the object. First, I am going to wrap these UVs correctly over the map. Any changes you make in the UV map will not be embedded into the 3D object until you commit to those changes. And to do so, you need to collapse the unwrap UVW modifier. The unwrap UVW modifier will always remember the origin state of UV map, the one that exists before adding the modifier. Once you collapse the modifier, the edited UV map will become the new origin UV map of the 3D object, and so on. By default, all the UV map manipulations occurred on channel UV1. Next, I will show you how to transfer the UV map between different channels, and also how to manipulate other channels UV individually. The viewport by default utilize only channel UV1 to render the assigned materials of the 3D object. All the materials and the nodes that you will create inside the material editor are settled to be rendered on channel UV1. You can change the wired UV channel of the selected material from the material settings. However, when you do render the 3D object, after changing one of the assigned materials UV channel, you will get this error message. You will eventually see this message because we did change the map channel from channel 1 to channel 2. But we did not create any UV map inside channel UV2 to render it usable. Add Unwrap UVW modifier to the object level. Then change the map channel to channel 2. Once you've done that, you will be greeted by this dialog from Autodesk. You need to select one of these options in order to proceed. Since we did not manipulate the origin UV map, choosing either Move or Abandon will not make any difference. Select Move to move the current UV map from channel 1 to channel 2. Select Abandon in case you did manipulate the channel 1 UV map, but you want to move the original UV map and discard any editing or manipulations. We are now in the channel UV2. Any manipulation of the UV map you will execute cannot be monitored in the viewport. However, you can perform a quick render to monitor the wrapping process. When switching to the mix node, you still get the mix node result in the UVW editor. Despite we are working on channel 2, and only maps with channel 2 should be visible in the editor. This can be considered as misleading information, and also another diminution of function inside the UVW editor. Any changes we perform on the UV map will be rendered on the channel UV2 maps only. Despite the presence of channel UV1 maps inside the editor. We can stretch these UVs to simulate splash dirt upon the caliper sides during speeding. And this is how we manage two separate UV channels. Channel UV1 is now assigned to display the diffused textures, and channel UV2 to control the dirt map effects. Whenever you need to edit or view the UV map in channel UV2, add Unwrap UVW modifier and switch to channel UV2, then select Abandon. In case you need to delete or remove any UV channel, add UVW mapping clear modifier, then select the channel number to delete or remove. By default, the modifier is settled on channel 0, which is a stationary number for non-existent channel to indicate the modifier off state. Once we decided to remove channel UV2, we will get the same error message for a missing UVW2 coordinates. Before removing or deleting any occupied UV channel, you need to change or disconnect any wired map or material that utilize the channel. Here is a comparison between two renders of channel UV1 and channel UV2. The left rendered image is for channel UV1, and the right image is for channel UV2. In this section, we will branch the mix node to add and test a color switcher node upon this compound object. When you start adding more branches to the mix node or the material, you can rename each mix node with a proper name to indicate its function and keep your materials organized. Procedural texturing is the term used to describe the process of creating material branches to add more effects upon the 3D object, and it is commonly used in visualization and visual effects. You can also call it shader. However, the term shader involves more than materials or nodes. It involves a programming language to display controlled effects or physics upon the 3D object. And shader is commonly used to describe materials inside the game engine, because each material is assigned to a certain group of effects or physics inside the game engine. We managed to add a color switcher. However, I would like to render the cavity areas over the geometry complete dark without adding any dirt or color effects. First, we need to change the diffuse map background color to complete dark. Change the diffuse map background inside Photoshop to full black. I have also changed the specular background to full black. We do not have any details in the black areas, and we do not need any specular over these areas. I am going to enforce the mask effect by wiring color 1 map to the mix amount value. In order to render this illusion perfectly, we need to make the background surface behind this object full black. you can control the output result of the mix node by editing the curve for mono, black and white values, or RGB for colors. However, this is like adding a post-rendering effects, and it does not affect the mix value. To control the mix amount of the wired maps, use the mix curve upper value to control the base color, or lower value to control the second color. When using 0, the map will be full visible, and when using 1, it will turn invisible. The values in between will gradually change the map visibility. In this section, we will uncover the Material ID. Whether or not you have assigned a material to the 3D object, every object you will create inside 3ds Max will automatically have a Material ID. The assigned Material ID is stored in the sub-object level, faces, or elements. In order to view the polygon Material ID, switch to either polygon or element sub-object level. Then you will need to select a polygon, an element, a face, a surface, or all to view the assigned Material ID. 3ds Max will automatically assign number 1 to all objects as initial Material ID. If an object has multiple Material IDs, the command panel ID input will be empty when selecting all polygons or faces of that object. Now, let's attach the wheeled components into a single object. Every time you try to attach objects with different materials assigned to them, you will be greeted by this dialog. Usually, I will go with option 1 or 2, and if you would do so, 3ds Max will automatically assign new IDs for the attached objects. To keep all the assigned materials separated and identified over the new attached object, polygons, or faces, those new IDs are assigned to the new attached objects in respective to the sequence you will follow during the attaching process. For instance, if we select the rim, then attach it to the rotor, the rim polygons will have ID 1, and the rotor polygons will have ID 2. These IDs will be reversed if we would select the rotor first, then attach it to the rim. Although, you can change the object polygon's ID from the command panel. The attaching process will keep following the same attaching sequence, and it will assign new IDs to the attached objects based upon their attaching sequence. If you try to change the Material ID of any polygons or faces within multiple materials IDs assigned to that object, the polygons will render the material of the new ID. when attaching multiple objects with multiple materials, 3ds Max will create a new multiple material for the new attached object. Inside the State Material Editor, pick Material from Object to view the created multiple material. The polygons can store numbers to identify the material. However, only the object level can store the material name. This multiple material name is assigned to the compound object level, and at the multiple material sublevel, the compound object is still divided by each material that was assigned to the three objects before the attachment. The multiple material will keep records of that. Thus, each one of these IDs has a material name as a reference to each object level that form this compound object. The material ID number is a primary key. You cannot have duplicated material IDs. All the materials IDs must be unique. You can change the assigned material ID from the multiple material sublevel table. However, when using an off-range material ID, the surface or the polygons will render black as an indicator of a missing material. The same will happen if you deleted any assigned material from the sublevel materials. If you disconnect any wired material to the multiple materials node, the polygons of that assigned material will be rendered black. Finally, if you changed the wired materials order into the multiple node, the polygons will render the new wired material regardless to its name. While the material names can be dynamically changed, the material ID cannot, due to its primary key nature. The last attachment option you want to choose is the one that we will use during the current attaching process. This option will not change the attached material's ID and will render the assigned material of the first selected object over the new attached compound object. After assembling the wheel parts into one single object, we can detach these parts again. However, the process required to return these parts and their assigned materials as they were before the attachments might consume a lot of time. Add PolySelect modifier to the object. Switch to the polygon selection from the modifier options, then select ID 1 from Select by Material ID. Collapse the modifier to Editable Poly. The selection we have made through the collapsed modifier is now stored into the Editable Poly. Switch to Polygons to view the selection. Detach the current selection to a new object with a proper name. Repeat the process until you detach all the wheel components. we managed to disassemble the wheeled components into new objects. However, each one of these objects still has the assigned multiple materials node, not the individual material. You can clearly spot that when trying to change the polygon's ID to the default ID 1. The detached polygons will always inherit the assigned material of their parent, whether this material is single or multiple. To remove the multiple material from the detached objects, you will need to disconnect all the wired materials to the multiple node. Then reassign each material to its corresponding object. You will also need to switch each object polygon's ID back to the default ID 1. I prefer to do the attachment or the assembling process of the wheeled components inside the game engine. When it comes to cloning a 3D object inside 3ds Max, there are different settings to choose from. In this section, we will discuss the main differences between copy, instance, and reference when cloning a 3D object. The main thing I would like to direct your attention to is when you clone an object with any of these methods. The poly count of the scene will increase by the number of cloned objects, whether they are cloned as copies, instances, or references. Right-click and choose Clone to clone the selected object in the same position as the original. This method works on both the object level and the sub-object level. Hold Shift while using the Move tool to clone the selected object to a different location or locations. You can also use the Rotate tool to clone an object. If you increase the number of the cloned objects, each cloned object will be separated by the move distance, or the rotation angle, from the original, multiplied by the clone number. The same concepts are also applied when using the Scale tool. When using reference method, it will create a clone dependent on the original, up to the point when the object was cloned. At this point, the reference method is similar to the instance method. You can create independent copy from both the reference and the instance methods. by making the clone unique, or by collapsing the cloned object to editable poly. The main difference between the reference method and the instance method is the clone dependency. When adding modifiers to the reference clone, the modifiers will affect the clone only. Thus, it will be independent from the original after adding those modifiers. However, any changes you make in the original will also affect the reference clone, with any modifiers added to it. The reference method is used to create assets resemblance with the possibilities of diversity at the same time. By collapsing the modifiers added to the reference clone, you will create independent copy from the original. The copy method will create a completely separate clone from the original. Modifying one has no effect on the other. That was a quick introduction for the cloning methods inside 3ds Max. Further applications might be discussed later in the future. When we started this project, we have decided to create only one wheel with its components separated, relying on the game engine that can clone copy other wheels so that we do not need to worry about them during the designing. After demonstrating the impact of the clones on the poly count, you really want to keep the overall poly count of your project as low as possible, not only for speeding the workflow, but also to save energy. Working with a very high poly count project can be very demanding, and it will put a load on your machine hardware, and by extension, your electricity bill. The one-wheel scenario can work smoothly inside any game engine, including the famous Unreal Engine. However, some people find that having 4 wheels is more handy than having only one. In this section, I will show you the 4 wheels scenario. We will adjust the UV map coordinates, if needed, and the wheels' locations. Moving an object at the object level will move the pivot of the object. If you want to keep the pivot at its location, move the object by any level of the sub-object levels. Keeping the pivot of an object at the world center is crucial, especially if you intend to use mirror or symmetry on that object. Otherwise, you may not get an accurate result. You need to align the pivot to the center of the world before adding the symmetry modifier. However, moving the current pivot location, which is also the wheel spinning center, can be problematic when trying to align the wheel's dummies to the wheels inside the game engine. The perfect setup for a sedan vehicle is to have an equal axle length in between the front wheels and the rear wheels. Obviously, that did not happen when we cloned the front wheel and move it to the rear. A simple, but yet a sloppy fix, is to increase the rear axle to match the vehicle body. Usually, the rear axle is longer than the front in trunks, or trailers, not in sedans. This is the easiest solution you can do, however, it is not quite the solution I would prefer to do. I will try to solve this in more professional way at the end of this chapter. However, let's keep it like this for now. After adding the symmetry modifier, you may notice the flipped texture over the mirrored wheels. Collapse the symmetry modifier, then add unwrap UVW modifier, and flip these UVs. The easiest way for doing this is by selecting the flipped elements, then adding the unwrap modifier over the selection. This will show only the flipped UVs that need correction inside the UVW editor. In either the one wheel or the four wheels scenario, we need to mark the location of each wheel spinning center. Before exporting this project to the game engine, we need to align all objects pivot to the world center. This will preserve the locations of all objects as intended inside the game engine. However, inside the game engine, we need to align each wheel pivot to its parent dummy. The pivot in this case will be used as reference to apply animation on the dummy children. The point is, the only logical way to center the pivot back to each wheel center is by aligning it to center of the object. Although this might sound the right thing to do, theoretically, unless you have a perfect primitive cylindrical shape or a circle. The center of each one of these wheels are not practically at the object center of volume. They are at each object center of mass. The object center of mass can be calculated by the sub-object levels distribution, usually the vertices. The object center of mass might not be at the same location as the object center of volume, or the diametrical center of the wheel. We have cloned these brake discs from an original at the center of the world, and by extension, each one of these cloned rotors are at the exact center of each wheel. Since they still maintaining their primitive shape, aligning the pivot to the center of each rotor will be the mark for the precise spinning center of each wheel. After that, it should be easy to align each wheel to its corresponding dummy. You will need to use the pivot as reference during the wheel alignment. I will proceed with the one-wheel scenario. Since we have marked the spinning center locations, there is no point for keeping these cloned wheels. I will keep the wheel components at the center of the world, except for the rotors. Then, I will assemble the wheel and align it to its corresponding dummy inside the game engine, where the engine can clone the others. However, we can simulate the whole process inside 3ds Max, and hear how it will be done. A foundation has to be built on something. No one can argue with that. One cannot build anything without establishing the bases first. Those bases must be built upon the right order of doing things. The same concept can be applied upon a vehicle, a house, a human society, and even a nation. It's the core that all things and beings are built around it. The purpose that gives life its true meaning. Since we did not follow the right order of doing things, we ended having this misalignment of the bases. From the beginning, we needed to even the wheel's axles by aligning the wheels correctly, then build the vehicle components over them. That could save us hours of work, rather than trying to solve the unsolved. I have sliced all the level of detail. To be more precise, I have sliced the parts that we need to correct. Although this might look easy, but it's not once you try it by yourself. The Move tool is not your first choice when it comes to correct such geometry misalignment. You cannot use the Move tool to move the vertices or the polygons of the front fenders to extend them. If you do this, you will disrupt the curved surfaces that extend from the front fender to the front bumper. In order to avoid spoiling these curves that we have already spent hours to perfect, I am using the Rotate tool in order to rotate the selected vertices and direct the tension caused by the rotation in a contained area. That I can actually control and adjust later by the Move tool. The contained area should be far from any curves that I cannot manipulate. I am refining the selected vertices to minimize the stress spot that will require correction later. This is not a first-shot trial. It could take some time, but eventually you will get the hang of it. Now, we can put those wheels upon the right path to ensure safety and endorse prosperity for everyone. Have a safe journey.